I'm Daniela.
And we're going to be showing you the difference between a concave mirror and a convex mirror. A convex mirror, the image is smaller and up, right side up. And in a concave mirror, it can be smaller or larger, and it's right side down.
So mirrors can be defined as smooth, and they have to reflect light. So in our spoon, on one side we're going to appear upside down, and then on the other side we're going to appear right side up. So this mirror, or this spoon, is just a special kind of mirror, and we're going to show you the different views that we are on this spoon. So this side of our spoon is convex because the image is smaller, as you can see, and it's right side up. And then the other side of the spoon is concave because we appear upside down. And a concave mirror can either be right side up or upside down, but in this case it's upside down.
This is our drawing of a ray diagram of a concave mirror, and we'll show you how light is reflecting off the mirror to create the inverted image. First, you have a ray of light that goes in parallel to the mirror and reflects back through the focal point diagonally. Then you have a ray of light that goes diagonally into the mirror and reflects back parallel to create the inverted image. And where the two rays meet is where your image is going to be formed. So our image is upside down and inverted. So inverted and diminished. First you have a line that's going parallel into the convex mirror, but since it's a convex mirror, it's going to reflect the ray back diagonally. But as you can see, it's going to create a virtual image behind the mirror. So we're going to act like the ray went through the mirror diagonally with the first ray that bounced off. Then you have a ray that goes diagonally, like it's going to go through the focal point, and then it reflects back parallel off of the mirror. Then when it reflects back parallel, it's going to create a virtual image of a dotted line behind the mirror, and where the two rays meet is where the virtual image is going to appear. So the image is virtual, diminished, and upright. That was the end of our analysis and explanation on how a mirror portrays a concave and a convex mirror.
And so finally, the front side of a spoon is going to appear concave because it's upside down, and the back side of a spoon is going to appear right side up. The next phenomena we chose to do was the Doppler effect, and that's when you can hear things softer, and then as something comes closer to you, you'll hear it louder, and then as it leaves you, you hear it softer again.
And the example we were taught with this is when an emergency car or ambulance goes by. When it's first coming up, it's kind of a soft pitch, but as it's like right in front of you or just moving past you, it's the loudest pitch. And then when it moves past you again to go away, it goes back to a softer pitch. In our experiment, we decided to have Daniela driving in her car with all her windows down, and she played the music super loud. We did it at Eastridge, where there was a long path that she drove down, and she started on the left end, and I was in the middle, and she drove past me. And we did one where she went faster, and we also did one where she went slower. And we realized that when she started up here, I perceived the frequency as lower, but when she came to the middle, or like right in front of me, I perceived the loudest of the pitch. And then she drove past me and the music got quieter and the pitch was lower.
So to continue analyzing this, the loudness of sound relates to the amplitude of a wave, and this can be seen with an ambulance or the how we did it, which was with the music playing in a car. So since the waves are closer together when coming toward you, the perceived frequency is going to increase. And when I drove away from Emma, the perceived frequency decreased because the waves were farther apart, so she heard the music softer.
Another everyday example of the Doppler effect would be when people are walking in school with their music playing. They'll start from lower blue and the office won't be able to hear the music as loud, but then when they start going to lower gold, it'll pass the office and the office can hear it louder. Then when they start going to lower green, then it'll be quiet again and have a low pitch. But we all know that the office will still chase them down to try and get them to stop their music.
So to conclude, the Doppler effect is a shift in frequency for the sound waves that is made by a moving source, such as the car with music on.